Although space may appear to some to be the final frontier, scientists are still actively discovering new things about our own little planet, including the mysteries that exist beneath its surface. A molten outer core surrounded by a highly packed ball of solid iron alloy has been widely accepted by scientists for more than half a century. However, new research provides a rare glimpse into the planet's interior structure, far stranger than previously assumed. Let's take a look at the incredible world that scientists are revealing beneath the Earth's crust and its strange shape-shifting enigmas. What lies at the core of our world may leave you baffled. Eratosthenes, a Greek polymath, made the measurement of the distance around the Earth's sphere more than 2,200 years ago, and it has been evident ever since that it must have a center. For decades, we've known that we do not live on a disk, but on a ball-shaped planet, which goes hand in hand with the notion that Earth has a definite center. It is common knowledge that our planet is made up of an eggshell-like crust over a thick mantle surrounded by a super-hot core, which most people learned in elementary school. Researchers have produced some fascinating, bizarre, and significant discoveries in the last 10 years that can help flesh out this image even further. Recent subterranean discoveries include a river of liquid metal that moves faster than tectonic plates, bubbles at the crust-mantle boundary, a new species of mineral capable of holding water hundreds of miles within the mantle, and magma chambers where rocks are heating up like popcorn and get expelled. Studying the inner workings of our planet is somewhat like diving into the ocean's depth. Research has relied heavily on the creation of equipment that can feel what lies beneath the Earth's surface, because humans can only travel so far into the planet's interior, which is 3,963 miles deep. The existence of tectonic plates was proven only when sonar was employed to study the ocean floor 50 years ago. Why is it so difficult to get down there? To begin with, stress and pressure make it hard to get down. You'd feel the weight of 131 elephants pushing down on your head just 8 miles down the road. It's also terribly hot down there. Nearly 1,600 degrees Fahrenheit characterize the temperature at the crust's deepest stratum. That's nothing but a breeze compared to the temperature of the Earth's core, which is estimated to reach 10,800 degrees Fahrenheit and hotter than the surface of the Sun. Humans have only made it 7.6 miles down the Earth thus far. Geophysicists use seismometers in the exploration of the Earth's core. In the same way that X-rays can see within our bodies, seismometers can see inside the Earth. Although we can't feel the movement of the crust beneath our feet, scientists are always keeping an eye on it. Due to the gravitational influences of the Sun and Moon, Phoenix, Arizona rises and falls by around 40 centimeters twice a day, and around 10,000 earthquakes strike Southern California each year, the most of which are magnitude 2 or below. Seismometers capture seismic waves created by each of these quakes and every rise and fall in the Earth's crust. Like an X-ray machine, a seismometer measures how energy passes through items to infer what's going on within. More so, scientists have been baffled for years by the existence of 2 gigantic rock blobs beneath the Earth's surface that seem to have no explanation. Many hypotheses have been floated, including the idea that they are massive chunks of an alien world. 2 experts have discovered some fascinating new information about the 2 enormous masses in their search for answers. Approximately 1,800 miles below the surface, at a depth of about halfway to the Earth's core, are rock blobs the size of continents, each one 100 times higher than Mount Everest. One is beneath the continent of Africa, and the other beneath the Pacific Ocean. As expected, the blob under Africa is far higher than previously thought. As a matter of fact, it's about 620 miles taller than the one on the other side of the Earth. That's not all though. Furthermore, the African rock blob has been discovered by experts to be denser and less stable. However, on the other side, the continent has experienced far fewer supervolcano eruptions over time, which may explain why things are the way they are. Aside from having a different temperature than the rest of the mantle, scientists believe that these massive blobs have a distinct chemical composition as well. According to the slowing and speeding up of seismic waves at their edges, we can deduce from the blob boundaries that they split into two distinct waves. One that travels within it and is slower, and that continues along its outer margin at regular speed. The simplest answer, according to scientists, is that the blobs are chemically separate. However, even though scientists aren't sure what the blobs are comprised of just yet, they can discern that they are more thick and stable than the matter around them. In addition, they are probably fueling volcanoes. Both historical and present, volcanoes can be found above the blobs, ranging in size from modest to large. The hotspots that generated Hawaii, Samoa, and Iceland, for example, are all supplied by extraordinarily deep magma plumes that appear to be linked to the blobs. As a result, we must ask, where did these blobs come from? One intriguing possibility is that they're leftovers from the origin of our planet. Relics of some primordial layer of the Earth that eroded over billions of years due to convection. From below, our core cooks the mantle rock, which makes up about half of the Earth, causing it to churn and move slowly. A time-lapse of Earth's rocky mantle over millions of years would show it swirling around like smoke around a flame. Some of the material may have been whirled into continent-sized lumps. Deep mantle plumes, which are columns of hot rock that explode violently when they push through the surface, are one of the principal theories surrounding the mysterious things beneath the Earth's surface. Another notion is that the blobs could trigger kimberlite, a reaction that pushes diamonds to the surface of the Earth. Scientists develop new models that indicate the blobs may move and shift considerably more than was previously considered possible. When the blobs change shape and migrate, they behave like continents and supercontinents. They are currently arranged in what is known as superblobs, which are formed when many blobs come together. They will eventually fall apart again, which will allow the process to continue indefinitely. A long-held belief was that the blobs were immobile anchors, but a new study has proven this is not the case. The study also discovered that the mass beneath Africa could have formed in its current form as early as 60 million years ago, a far shorter time frame than previously thought. 60 million years is a considerable period for our species, but it's not so long on a cosmic or even planetary scale. The Earth originated around 4.5 billion years ago, to put things in perspective. Furthermore, research suggests and agrees that the movement of the tectonic plates may be linked to the blob's formation. Despite our growing understanding of blobs, there are many unsolved questions. A lot of things remain a mystery, including how and what exactly the blobs were composed of. Continued study will undoubtedly uncover additional information about these blobs and provide answers to these questions. These investigations would not only shed a light on the origins of our planet and the processes that shape it, but they would also have applications in the real world. The minerals connected with the blobs may be tracked more easily if scientists understand the blobs better. Various energy technologies rely on minerals such as diamonds and nickel, which can be found beneath the surface of the Earth. You might find blobs fascinating, especially if you didn't know they were floating between our planet's surface and core. The more we study the blobs, the more interesting information we'll uncover, and perhaps we'll discover a better technique to mine key energy resources while we're doing it. The layers underneath the mantle are also incredibly complicated. The Earth's inner core is a 760-mile wide iron ball located deep within the planet's interior. Despite being hotter than the Sun's surface, seismic tests reveal that it is composed of iron crystals that are held rigid by enormous pressure. As the planet's youngest primary structure, it began forming when liquid core material began freezing off. Further complicating things, the planet's inner core rotates a little quicker than the outer core. We still don't know a whole lot about the inner core structure. Increasing seismometers' numbers, diversity, and sensitivity will be critical in making future discoveries, whether on Earth or elsewhere. Our ability to study blobs, the Earth's core, and a host of other topics will expand as we add sensors to our arsenal. All Earth's onion layers must be linked to the formation of our planet to explain how it evolved into the life-friendly environment we enjoy today. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.